The first type of factoring involves GCF. And what does that stand for? Greatest common factor. So there'll be several problems where you need to know how to find the GCF. The second type of factoring you probably learned in class was probably factoring by grouping. Y'all remember that? Okay. The third type of factoring that you'll see will probably look like this: a squared minus b squared, and that's called the difference of squares. So that's the third type that you should have learned in class, the difference of squares. Y'all see that or no? Okay, the four, you might, I don't know if you need to scoot over, man. The fourth type of factoring that you need to know how to do is trinomials that have a lead coefficient of 1. If you notice that problem, in front of the x squared you have a 1. You don't have another number in there. So that's totally different than the fifth type of factoring, ax squared plus bx plus c, where there's a number in front of the x squared. That's called a trinomial with lead coefficient other than 1. Okay. So those are the 5 types we look at. In algebra you have other types of factoring, but in this class that's mainly what we use. Okay. So let's get started. Does that make sense? Y'all familiar with all of those? Or seen them at least? All right. So let's take a look at some of the factoring that you will see. All right. So from this first pack, hopefully all of y'all have a packet. If you don't have one, I think they have some extra ones in the back. No more extra ones? Okay. All right. So here's some types of factorings that you might see on the test. And so let's go over these. I'm not going to go over all of them, but let's start on a couple of them. Let's start with number 1. If you look at number 1, the problem will say factor each expression completely. That's what it'll say on the test. And again, I can almost assure you your first 10 to 15 problems you need to know how to factor. If you can factor, you'll be able to make it through half of this test without a problem. All right, number 1. If I had to factor that problem, how do we get started? You see anything common? Yeah, that's the first thing you always do is look to see if there's something common. So we start with the numbers first. We got a 27 and 18. What's common in both of those? 9. So we can actually factor out a 9 and just kind of put it on the side like that. And I always put it on the side because I like to work underneath my problems. All right, so forget about what's left over. Let's figure out what's common right now. Let's go to the A's. I have an A2 and I have an A1. What's common there? A. We have an A in both of those, so we can pull it out as well. And then I go to the B's. I have a B3 and I have a B2. Both of those have what? They both have B squared in them. Very good. So we can pull that out. Now that's your GCF, right? So now I'm going to put a set of parentheses and I'm going to determine what's left over. And that's kind of the way I'm working. I'm pulling out the GCF and then I ask myself what's left over. Okay. So now that you took that 9ab squared out of the first term, meaning right here, you pulled it out of here, what are you left with? You're left with a 3, because 9 times 3 gives you the 27, right? You had an a squared, but you pulled out an a, so what do you need? I need another a. Very good. I got a b3, but I pulled out b2, so how many left? You got one b left. Very good. So that's the first term. You're done with it. Does that make sense? Okay, then we'll go minus. All right, I'm going to do the same thing again. I'm going to say, okay, I pulled this GCF out of 18ab squared, and I want to know how much is left over. And what's left over? 2. There's a 2 left over. Well, you only had one a, and you already pulled out one a, so no more a's. You got a b squared, but you already pulled out b squared, so you're done at that point. That's it. You'll probably have 1 or 2 problems on the test related to that. So if you can do that, that's a couple of points right there. That makes sense? Yes. That's an example of a GCF. Okay, let's move to I want to do a grouping problem first. Do you see a grouping problem on here, by the way? Yeah, kind of like number 3 and number 9 is a grouping problem as well. Yeah, so let's do 3 first, and I'll do 9. And then I'll do one of each type. Okay, number 3 says factor. Okay, remember the first factor we learned in this class was GCF, right? All right, do you see anything common in number 3? Yes. What's common in both of those? You got an a minus b, right? So what you can do with number 3 is you take that a minus b and just kind of put it on the side like we did earlier. We just put it on the side. And then we ask ourselves a question. What's the question? What's left over? When you took the a minus b out of the first term, out of right here, what were you left with? Just plain x. That's it. And then when you took the a minus b out of the second term, what are you left with? You're left with an 8. You're done. Y'all can't tell me that's not easy, right? That's pretty straightforward. Okay, you'll probably have something like that. Let's go on to number 9 real quick, because I want to keep all of the grouping stuff together. And I'll come back to that in a minute. All right, look at number 9 real quick on your paper. And actually, the final exam kind of flows just like your paper flows, really. The first thing on your final exam packet is factoring. So on the test, the first thing you see is factoring. The second thing you see is rational equations, rational expressions. On the test, that's where they fall, right after factoring. Let's look at number 9 real quick. All right, number 9 says, I want to factor mx plus my minus nx minus ny. All right, so the question I would ask you first is, what's common in all 4 of those terms? And the answer is nothing, right? So with nothing common, we got to go to plan B. So there was nothing common. What is plan B? Plan B is to see if I can group them maybe. And grouping meaning, can I put stuff together that's alike? If you look on number 9 and you look at that mx and that my, what do you see? They both have an m common, right? So we can group those together. That's the name grouping. All right. And if you look at the last 2 terms, negative nx and negative ny, they both have an n common. Actually a negative n. Okay. So let's see how we do that. All right. So with the mx plus my, you said what was common in both of those? M. So you can factor out the m, and what are you left with? You're left with x plus y. Very good. All right? So we're done with that part. And so you got to learn how to work these problems in pieces. A lot of times the problems that people make is they look at the big picture. In math, you got to work in little pieces. And then as you put these little pieces together, you slowly come up with the solution. So I've done the first piece. Let's go to the second piece. So I got a negative ny and a negative nx. What's common in both of those? N. It's actually going to be negative. And the rule is if the first term is negative, then you have to pull out a negative. So I'm really going to pull out or factor out a negative n. So I actually have to put negative n. I can't just put an n there. I got to put negative n because they both have negative n in them. And then I'm going to ask myself, what question? What's left over? I mean, that's the question. All right, what's common? What's left over? All right, so when you take that negative n out of the first term, what are you left with? You're left with an x. And then somebody said x minus y, right? That's what you said. But something wrong with that, right? Is there something wrong with that? Yeah, because if you look at these two, they're not the same. They're supposed to be the same. Well, remember when you pull out a negative, all your signs change. Whenever you pull out a negative, see how that x became positive? So that y needs to become positive as well. See, you know something is wrong if this is x plus y and that's x minus y. You know at that point you've done something wrong. Because these two things need to be the same in order for you to factor. All right, so now that did y'all understand that? Because y'all got to say something. Because y'all looking kind of crazy at me. Like, I mean, y'all got to say something. If you don't understand, I'll be glad to cover it for you. Because a lot of times, this finals are very important for a lot of you. I know in my class, I got several students. The only way they're going to pass is if they pass the final. So if any of you in that position, you got to ask questions. You got to be comfortable asking questions. I'll be glad to clear up anything you need. All right, so now that we've done that, we go back to the way we did number 3. What's common in both of these? There's an x plus y common in both of these. And what are you left with? M minus n, and you're done. And that thing is completely factored. Okay, so far we looked at a GCF problem, and now we looked at 2 grouping problems. Do those make sense? Maybe 3 of those on the test combined. All right, so let's go back to difference of squares. Now look at number 4 real quick on your paper. And my question to you would be, can we factor that? Is that the difference of squares? Is that the difference of squares?
Yes.
Yes? Okay. Let's see. Anybody agree with that or disagree? For those of you that just came in, we're looking at these 5 techniques. We're looking at GCF, we're looking at grouping, we're looking at difference of squares, We're looking at trinomials with lead coefficient 1 and trinomials with lead coefficient other than 1. So my question to you now is number 4 the difference of squares?
Yes.
Who said no? And why do you say no?
The difference is subtraction.
Yeah, the difference means subtraction. So the fact that right here it has a plus, that means that's not the difference. But it is 2 squares on both ends, right? So can we factor that? Is there a GCF in it? No. Is it the difference of squares? No. So at this point we simply say what?
So if that were a negative, it would be a difference.
If it were a negative, and if there were a subtraction problem, yeah, it'd be a difference of squares. So when it's not the difference, then it's not factorable. There's nothing you can do in this class to make that work. You can't multiply 2 things together in this class to make that work. Now when you get to college algebra, they'll introduce a different set of numbers to you, then you probably can factor that. But look at number 7, however. Look at number 7 real quick. Can y'all see number 7? All right. Now if I look at number 7, that's a little bit different, right? All right, so this is how I would look at it if I was sitting there taking the test. I say, okay, can I do a GCF? GCF, anything common in both of those? Not in both of them. Remember, it has to be in both of them. So there's nothing common in both of them. Checklist number 2, can I group these things together? Nope. Is it the difference of squares? Yeah, right? You got a square on one end and a square on the other end, right? You got, how do you get 1? What 2 numbers multiply together get 1? What number times itself? 1. 1 times 1 gives you 1. And how about 25x squared? What do you multiply to get 25x squared? 5x, right? Because 5x times 5x will give you 25x squared. These to me are probably some of the easier ones because once you realize you have a difference of squares, you make 2 sets of parentheses, put a plus and put a minus in there, like that. So I go ahead and make 2 sets of parentheses. I make 1 parentheses a plus and 1 a minus. Y'all got that? Okay, now, what did you say multiplies together to give you 1? 1, right? So we put 1 in front because 1 times 1 gives you 1. You're done with that part. Because 1 times 1 gives you 1. And what did you tell me gave you 25x squared? 5x. So now we put a 5x in the back and we are done. Just that simple. 1 plus 5x, 1 minus 5x. And if you did the FOR method, now let's say you're not certain. So then what you do, if you have time, and you should have time because your test should be 2.5 hours, you go by and you do the FOR method on it. 1 times 1, 1, right? 1 times negative 5x, negative 5x. 5x times 1, positive 5x. Negative 5x times negative 5x, negative 25x squared. And then what happens? The 5x is canceled. And you end up with what? 1 minus 25x squared. So you can check your work on some of the problems. If you're not certain, just FOIL it back out, see if you get what you started with. Does that make sense? Okay, so that's a look at GCF. That's a look at grouping. And that's a look at difference of squares. That make sense? All right, let's look at a trinomial with lead coefficient of 1, like problem number 2. I know you're going to get tired of me asking you the checklist, but I always ask my students, okay, let's go through the checklist. Number 1, you check to see if you can do what? GCF. So in number 2, do we have a GCF? Anything common in all 3 of those? No. Okay, so we can cross that off. Can we group them together any kind of way? No. Normally grouping problems will have 4 terms. Not all the time, but normally they will. Can we group them? No. Okay. Checklist number 3. Is it the difference of squares? No. Difference of squares would normally have 2 terms, not the difference of squares. Is it a trinomial? Does it have a lead coefficient of 1? Yes. So we know what we're working with. We got a trinomial with lead coefficient of 1. How do you do those? You look at the back number. And in this case, the back number is what? Negative 15. Okay? So you write that on the side of your paper. And all you do is write everything down, the factors of negative 15. What 2 numbers multiply to give you negative 15? Yeah. if you went through the whole list, you would have positive 1 times negative 15, negative 1 times positive 15, right? Positive 3 times negative 5, negative 3 times positive, and so on, right? But we need two numbers that multiply to give me negative 15, but those two numbers, when you add them together, they have to give you what? Negative 2. So which two of these do we need? We need the positive 3 and the negative 5, right? And that's it. Once we figure that out, we're done. Now we can say what? X positive 3 and X minus 5. And I'm done. Once you find the two numbers that you need, you stick them in your parentheses with an X and you're done. And if you wanted to check that, how will we check it? We will simply FOIL it out and make sure it ended up with what we started with. And that's an example of a trinomial with lead coefficient of 1. Now, if you look at number 9, or number 5, rather, if you look at number 5, look at number 5. And I can almost assure you you'll have one like that on the test. Can't guarantee it, but I always see one like that. I see that normally on the test. Checklist again real quick. GCF? Nope. Grouping? Grouping, yes, no? No. Difference of squares?
No.
Trinomial lead coefficient 1?
Yes.
Yes, it's a trinomial lead coefficient 1, right? All right, so how do we get started on this problem? How do we get started? You look at what? You look at the back number on. I'm not going to worry about the y square right now. Just look at the number. The back number this time is what? Positive 9. And the middle number is what? Positive 6. So we need two numbers that multiply to give me 9. But these same two numbers add together and give me 6. So what two numbers do we need? We need a very good. We need a positive 3 and we need a positive 3. Does that make sense? Why? Because 3 times 3 gives you 9 and 3 plus 3 give you 6. So those are the two numbers we need. All right, so once we get those two numbers, watch this. We make our parentheses, two sets of parentheses, and we have x plus 3 and x plus 3. Are we done?
No.
What's wrong with that?
You need to put your Y's in there.
Yeah, this problem actually had a y square at the end. And because it has a y square, we got to take care of that y square. But what time what give you y square? What time does it say?
Y.
Yeah, y times y. So just stick a y on the end and you're done. Now, yes, ma'am.
What happens to the X? I always wonder.
All right, I'm going to multiply it out for you. You'll see it. That's a good question. Says, well, what happens to the x, y in the middle?
I can get the answer, but I always just wonder what happens to that one.
All right, I'll multiply it out and you'll see it. Now, let me show you how this answer may look on the test. So let's say you got that, x plus 3y, x plus 3y. You looking on the test and you looking for that answer and you don't see it. Most likely what they did is said, okay, you really have x plus 3y how many times? Twice. So they might write that as x plus 3y squared as the answer. So it could come either way. But most likely they'll put it x plus 3y squared. Now to answer your question, the question is, okay, that don't really look like it'll give me what we started with, right? I mean, how did we get what we started with? Well, let's multiply this thing out using the FOIL method real quick, and then we need to move on. Okay, if I had to multiply this thing out using the FOIL method to check it, tell me what to multiply and tell me what we get. Tell me what to multiply.
X times X.
X times X, and what do you get?
X squared.
X squared, very good. Okay, what else?
X times 3y.
X times 3y, and what do you get?
3yx.
3xy, right? Normally just keep them in alphabetical order. 3xy. Then we'll multiply 3y times x, and what do we get?
3xy.
We'll get another positive 3xy. And then what else do we multiply?
3y positive 3.
And what do we get?
3y squared.
We get 9y squared, right? Yeah, we get 9y squared, right? Then when you put your like terms together, you get x squared plus, you got 3 of these, you have 3 more of these, so you actually have what? 6xy plus 9y squared. So we know that it works. So sometimes it's hard to see when you factor it that thing actually gives you what you started with. So that's an example of two problems that are trinomials with lead coefficient of 1. Okay, we got one more left. Am I going too fast? Okay, I got one type of factoring left, and that is a trinomial with lead coefficient other than 1. For example, number 8. Let's take a look at number 8 real quick. Let's take a look at problem number 8. And again, I'm going to go through the checklist. My students hate when I do it, but that's the way I try to get them to learn how to factor. I go through the checklist. Do I have a GCF? All right, and this is what you need to do whenever you're taking your test. Sit down there, you see a factoring problem, go through the checklist. Do I have a GCF? The answer is no. Can I group these things together? The answer is no. Is it the difference of squares? No. The answer is no. Is it a trinomial with lead coefficient 1? It's a trinomial, right? But it doesn't have a lead coefficient of 1. Is it a trinomial with a lead coefficient other than 1? Yes. Okay. All right. So now we know what we're working with. Now this is the way I factor my problems, and everybody factors different. Ms. Baker will be up here earlier and later, and she'll probably do it a totally different way than I do. So what you always choose whatever method you like best. I don't think we care what method you use. Whatever you use works for you, use it. Okay, but this is the way I factor mine. When I know that I have a trinomial with lead coefficient other than 1, I start by multiplying the 5 times the negative 8. That's the way I get started. I know you might not have seen this method before. Your teacher may teach the trial and error method, or they may teach a different method. I've been teaching 20-some years, and we all do something different. Just depends on where you went to school and how you learned it. This is kind of what I learned. So I said 5 times negative 8, and on the side of my paper I said, well, that's equal to negative 40, right? I said that's equal to negative 40. All right. Now, once I know that I have a negative 40, I go, okay, I need two numbers that multiply to give me negative 40, but those same two numbers need to add together and give me negative 6. And I don't know, we got to look for it. We don't know right off the bat, right? So let's see, 1 and 40, there's no way that's going to give it to me, right? 2 and 20 is not going to give it to me. We eventually get to 4 and 10. But we need to be specific. What kind of 4, what kind of 10?
Minus 4 plus 10 plus.
Sure? He said negative 4 and plus 10.
Yeah.
Yeah? Yeah, and that's what you got to be careful of. We actually need a negative 10 and a positive 4. And again, if your teacher's doing it a different way, just keep doing that way. So I say, okay, I need a negative 10 and a positive 4. And why do I need that again? Tell me again why I need those two. Because when you multiply those two, they give you negative 40. And when I add those two, they give me negative 6, right? All right, now here's where my method differs. Now, once I do that, I look at the number that's in front. And what's in front? I put the 5 underneath here like this and create a fraction. And you may not like this, so just bear with me. I'll do another one so you can see it. I put the 5 underneath there like that. If that would have been an 8 in front, I would have put the 8 in front. Would have been a 2 in front, I would have put the 2 in front. Doesn't matter. All right. Now you have to reduce these things. This thing right here reduces to what? 10 over 5? Negative 2. I'm going to put negative 2 over 1. You normally don't put a 1. I'm going to just put the 1 right here. Now, can I reduce this 4 over 5? So I'm going to leave the 4 over 5 just like it is. Y'all follow me so far? Found two numbers that gave me that. I put the lead coefficient underneath. Now watch this. Once I get that fraction down there, watch this. Once I have these fractions right here, I'm ready to factor. That 1, that becomes 1x minus 2. 1x minus 2. Y'all see what I did right here? 1x minus 2. This will become what? 5x plus 4, and you're done. And to me, that's the easiest way I've ever seen it done. The trial and error method, you have to sit there and try to figure out, okay, do I need a plus? Do I need a minus? You have to figure out a lot of things.
Are you teaching college algebra next month?
I never know what I'm teaching. Hey,
Tanisha Carrington. Tanisha, somebody left this in the wrong 405. Tanisha here?
That's 300 is next door.
Oh,
That's
yeah.
the 03, yeah.
Oh, okay.
I'm sorry.
Sorry, I'm sorry,
Yeah, yeah, 300 is next door. All right, so let's do one more like that, so you can get some, because these are the problems that the students miss the most. The lead coefficients of 1. All right, so real quick, let's look at number 12, and we're gonna try that same technique and see if you like it. If you don't like it, I can show you other ways. That's just the way I like to do mine. But again, you can do whatever you like. We are here to please. All right, so take me through the checklist real quick. Factoring checklist. Y'all take me through it real quick. First thing you look for, what? GCF. Yes or no? No. Next thing. Grouping. Can we group? No. Next thing. Difference of squares. Different squares? No. Trinomial with lead coefficient 1? No. Trinomial lead coefficient other than 1? Yes. Okay, so now we know what we're working with. I mean, that may be very trivial to you to do that, but to me that's very important to know what it is you're working with. So we know right now we're dealing with a trinomial with lead coefficient other than 1. How do we get started on that problem? Multiply the 4 times the negative 3. And what do you end up with? Negative 12. Thank you. Right? Now, so we need two numbers that do what? That multiply to give me negative 12, but the same two numbers have to add together and give me positive 11. What two numbers do we need? Positive 12 and negative 1. Does everybody see that? Positive 12 and negative 1. That's what we're looking for. That's what we need. Good. So we're in good shape. All right. What's the next step? Whatever your lead coefficient is, and in this case your lead coefficient is what? 4. So we're going to put the 4 underneath here like that. We're going to put the 4 underneath there like that. The only way this method works is you have to reduce when you can. Can we reduce that 12 over 4? Yes. And what does it become?
3.
Positive 3 over 1. And can we reduce this negative 1/4? No. All right, so we're ready now. Once we get those two, we're ready. We are now ready to factor. All right? So, with that in mind, we got our fractions. Using this fraction right here, what is it going to be? That's going to be x plus 3. Everybody understand that? The number at the bottom goes up front with your x. Negative 1/4 becomes what? 4x minus 1. And you're done. Now, in the event that they ask you to solve this, let's say they ask you to solve this. Let's say instead of factor, they would have said solve. Here's the beauty of doing this method. Had they said solve, this would have been equal to 0, right? This would have been equal to 0. All right, had they said solve it, when you find these two numbers right here, you take the opposite of those, and those will be your answers. What's the opposite of positive 3? That's one of your answers. What's the opposite of negative 1/4? That's your other answer. So if they would have asked you to solve this thing, your answers will always be the opposite of these two fractions. Does that make sense? Oh, don't worry about it. Y'all don't look like y'all like that. Don't worry about that.
Thank you.
Yeah. Yes. Yes, sir.
Will the first fraction always be able to reduce? Will it always?
No, sometimes you can do them and nothing reduces, so you just keep the bottom with your x. It doesn't matter. So, for example, let's say technically you would have done everything. Let's assume that at the end you had a negative 3 over 4 as one of your fractions and a positive 5 over 7 as your other fraction. So let's say you would have gotten that. And nothing reduces, right? Neither one of those reduce. So then you just would have just go ahead and do your factoring. What would it be? 4x minus 3 and 7x plus 5. So sometimes that'll happen. It doesn't happen a lot, but sometimes. Does that make sense? So that's all you're factoring right now. So what are your 5 types? GCF, difference of squares, grouping, trinomials with lead coefficient 1, trinomials with lead coefficient other than 1. And that's all the factoring I'm going to do. Unless you have a specific one you'd like to see. Any particular one you'd like to see from section 1? 14. Number 14? All right, let me do number 14 real quick, and we will. I don't have a 14. Do it. What does it say? What does 14 say?
6x squared plus 17x
Okay.
minus 14.
All right, I'm sorry. I don't have that one. What is it now? 6x squared
6x squared plus 17x minus 14.
minus 14. Okay. All right. And that's a typical trinomial with lead coefficient other than 1. So how do we get started? First time last, right? 6 times negative 14 is negative 84. That's going to be a little bit harder because we got to find some numbers that give us 17. All right, so let's see. 1 times 84, no. 2 times 42, no. Right? 3 times 28, no. How about 4 and 21? What about 4 and 21? That'll work, right? So what kind of 4, what kind of 21? We got a positive 17. So a positive 21, but a negative 4. And why do I use these two? Because these two multiply to give me negative 84. These two add together to give me positive 17. Now, the lead coefficient this time is what? 6. So I'm going to put a 6 underneath. Now, here's an example of where both of these reduce. And when I was doing one earlier where one reduced and the other one didn't, both of these reduced. Let's reduce to 21 over 6. What do we get? Doesn't 3 go into both of those? Yeah. That becomes 7 divided by 2. And the negative 4 over 6 reduces. That becomes what? Negative 2 over 3. Negative 2 divided by 3, right? All right, now we're ready. That's why I like this method, because once you get the fractions down, you're pretty much ready now. So what are the factors going to be? 2x plus 7, 3x minus 2, and you're done. And you're done. You could actually multiply these out if you wanted to check that. You could do the for method on this to assure that you have what you started with. So you want me to do another method, or y'all don't like that, I can do another method. Yeah. The other method is trial and error. The way the book teaches it is trial and error, where you have to actually take the factors of the 6, take the factors of the 14, and kind of play with them until you come up with the answer. It's a lot of guesswork involved. That's why I don't like that method. It's a lot of guesswork involved there. So that was number 14, I guess. Now, all right, so let's look at...
What would you call that method? Is it a name for that method, or that's just where you...
Somebody told me it was called the Ghetto moves method. I don't know where they got that from, but that's what somebody told me. I have no idea where it came from. Somebody told me that. But it works every single time. I couldn't show you anything that works sometimes and not all of it. It works all the time. All right, let's look at problem number 2, because we want to, anything, 2 is just factoring, right? So you're not going to have, you shouldn't have too many. If I look at number 1 right off the bat, I'm not going to do it. What do you see right off the bat in problem number 1 in section 2? What? There's a what? But the first thing I see on number 1 is what? What's the first thing y'all see? Come on, what's the first thing y'all see? GCF, right? The first thing you should see with that problem is a GCF. And that's how you get started. So let's go ahead and do this problem real quick. I thought y'all were going to respond a little better than that. So if you look at all of the numbers, they all have what? 7. However, the first term is negative, so we really need to pull out what? We need to pull out a negative 7. Because the first term is negative, you have to pull out a negative. Let's move to the x's. I got an x3, I got an x2, and I got a y. An x2, x3, and an x. What can I pull out? I can pull out an x. Let's move to the y's. I have a y1, a y1, and a y1. So all I can pull out is what? Y. And then what's the question you ask yourself? What's left over? That's the question we ask. What's left over? All right? So you took a negative 7xy out of the first one. You took it out of there. What are you left with? You're left with 2x squared. Right? All right, what? You took a negative 7xy out of the second term. Be careful there. What are you left with? Minus. Why minus? Remember when you pull out a minus, it changes everything. So you're left with a minus. Minus what? minus x. And you pull out a minus here, so you're going to be left with a plus 5. Now, the question would be, when I look in that parentheses, can I go any further? I mean, that has to be a question, because remember, it says factor completely. So you got to make sure you can't go any further. I'm going to check this real quick and see if I can go any further. 2 times 5 is what? 10, right? The middle number is there any way I can get a 10 and a 1? Let's see. 1 and 10, that's not going to give me 1 any kind of way. 2 and 5, anything else? That's it, so we're done. So we know we're done. When you know you can't find two numbers to give you that middle number, then you know you're done. Does that make sense? All right, so that's it. That's probably your first 10 problems on the test. Factoring. So the better you can factor, the better you'll be able to do on this test. Now moving on to section 3. These problems are from chapter 7, by the way, if you want to reference them later. These are from chapter 7. They are called rational expressions. They are called rational expressions. Now, the reason why we call them rational is because they are fractional in nature. In other words, they have a numerator, they have a denominator. And our job is to simplify them, right? So if I ask you something as simple as, okay, simplify 10 over 18, most of you would not hesitate, right? You say, if I got 10 over 18, you would say what? Well, 2 goes into both of those, right? 2 goes into the 10 5 times. 2 goes into the 18 9 times. And all of y'all would be comfortable with that. These problems work the same way, except they are algebraic in nature. So, for example, if I look at number 1, they tell me to reduce that to lowest terms. How do we get started? Got to factor, right? You have to factor first. You cannot start by saying, okay, that 2 and that 2, they look nice, I'm going to cancel them. That x and that x, I'm going to cancel. That's what everybody wants to do. In other words, let me show you what people do. They'll look at this problem right here. If they're not certain how to do it, and I wouldn't blame them if they did that, they would say, okay, that 2 cancels and that 2 cancels. They would say that x cancels and that x cancels, right? And then they would have 4xy over y squared. They might try to reduce it again. And what do you think answer choice A will be? Exactly the mistake you make. So they know the mistakes that you're going to make, and you're going to have, for example, that y would cancel, and you'd have, so answer choice A would be 4x over y. And you would be, okay, I got that. Boom, I got that one. That's going to be 1. So they know the mistakes that you're going to make, and they have the answer waiting for you. So you really got to know what you're doing. So instead, like he said in the back, instead we got to do what first? We got to factor. So let's look at the numerator. Let's look at the numerator. What can we do to that numerator? We just went over all 5 factoring techniques. What can we do with the numerator? GCF, right? Okay, so at the top we can pull out what?
2.
We can pull out a 2, and we'd also pull out an x. Very good. And when we pull that 2x out, what are we left with? 2y. Don't forget the 2, because remember you had a 4. 2y plus 1. Very good. All over 2x y squared. Okay, so now you factored the top. All right, now we can cancel, because we have multiplication here. What can we cancel? That 2 and that 2. We can also cancel that x and that x. What are you left with? 2y plus 1 divided by y squared. You're left with 2y plus 1 divided by y squared, and at that point you are done. So on this test, whenever you take it and you have doubt, think about factoring, because that factoring will normally get you going again. Most people are stuck when they don't know what to do, and a lot of times if you factor, it can get you unstuck. All right, so let's do number 6. Let's do number 6 real quick. All right, number 6. It says the directions will say write each fraction in lowest terms. And you see that. Okay, tell me what not to do. Because a part of learning something is also learning what not to do. So on number 6, what should you not do? Do not cancel what? Do not cancel those x squares. It's going to be real tempting to cancel those x squares because you got one at the top and one at the bottom, right? So it'd be real tempting to cancel that. And of course, I said if you do that, they will have the answer waiting for you. Okay, so let's do it the right way. What should we do instead? We should factor, right? So if you look at the top of number 6, that is a what? What is that? A trinomial with lead coefficient of 1. So all we got to do is look at the back number, trying to come up with the middle number. All right, so tell me what the two numbers should be.
2 and 1.
Okay, let's see. The back number is what? 1. Okay, so how do we get a 1? There's only one way to get 1. Only two ways, actually. 1 times 1, right? And -1 times -1. That's it. So which 2 do we need? Do we need the 1? Do we need the positive 1 and the positive 1, or the negative 1 and negative 1? Positive 1. So we really need x plus 1 and x plus 1. Why? Because 1 times 1 gives you 1, but 1 plus 1 gives you 2. And do y'all see that or no? Okay. Let's look at the denominator now. The back number this time is what? The back number is -2. So we need two numbers that multiply to give me -2. But added together give me what? And when they add together, they have to give me -1. So what two numbers do I need? What is it? Some of y'all are saying a +2 and a -1, and other people -1 and +2. Which two? We need the -2. So we need x minus 2, and we need x plus 1. Why? Because -2 times 1 gives you what? -2. And then -2 plus 1 gives you what? -1. So those are your factors. So now that we factored everything, what happens? Bam, bam, they gone. Final answer? X plus 1 divided by x minus 2. And do not do what? Do not cancel those x's. Right? Because they'll have that answer as well. Does that make sense? Okay, so that's a look at reducing. That's a look at reducing fractions or rational expressions. Let's move on to number 4 real quick. It's almost 6 o'clock already.
You started late.
I know. I got you. All right, number 4. On number 4, they're going to be asking you to do a couple of things. They're going to ask you to multiply, add, subtract, divide rational expressions, right? So the multiplication is pretty easy. Multiplication is a lot easier than the subtraction and the addition. The reason why the multiplication is a lot easier is because you don't have to have a common denominator. For example, if in the 8th grade you had the problem 1/2 times 3/5, and then somebody told you to multiply that out. You do not need a common denominator, right? You just go straight across, and what do you get? 3/10, right? 3/10, right? I know you knew that. I knew you knew that. So you get 3/10, and you'd be done. However, if somebody said, what is 1/2 plus 3/5, then you got a bigger problem, right? Because now you'd have to find a common denominator and go through all of that. So that's where we're heading with all of this. But right now, the multiplication is pretty straightforward. So I'm going to do number 2 for you real quick, and make sure you understand that, and then we'll move on to the addition and subtraction problems. All right, number 2. All right, if I had to factor the numerator here, and I'm going to start just factoring and assume that when you get home you'll see how I got this. On number 2, I get x plus 2, and I'd also get x plus 1. And I'll give you a second to make sure you agree with me. You agree with that? I'm doing section 4, number 2. How did I get that? Well, 2 times 1 is what? 2. And 2 plus 1 is 3. Trinomial lead coefficient of 1, right? All right, now let's look at the denominator. If you look at the denominator, I got 3x plus 9. So how do you factor that? What do? Pull out a 3. So you factor out the 3, and then you're left with x plus 3. Very good. Right? All right, and then over here we have x plus 3. I can't do anything at all with that one, so I'm going to leave it alone. And then in your denominator, you got x squared minus 4. All right? So x squared minus 4 is a what? A difference of squares. Very good. That's a difference of squares. Y'all remember that? So how do we factor a difference of squares? We're going to have x plus 2 and x minus 2. That's kind of, you see the importance of factoring now? Here we are in a totally different chapter, a different section of this final exam package, and we're still doing what? Factoring. That's why I'm stressing the importance of learning how to factor. So if you don't do anything else the next few days, practice your factoring. It'll get you through half of the test almost. All right, so now that we've factored all that, now what do? Now we just start canceling whatever we can. So we just got to look, let's see, what we got here. X plus 2 cancels with the x plus 2. That x plus 3 cancels with that x plus 3. That's it. So now we say the final answer is what? X plus 1 divided by 3 times the quantity x minus 2, and you are done.
You don't have to multiply that 3 in there?
Now, so the question is a good question. Do we have to multiply that 3 at the bottom? Now, normally they will leave it factored like that. If you look for that answer and it's not there, then you better start looking for x plus 1 divided by what? 3x minus 6. But most likely they leave it factored. But there's no guarantee that it will be factored. But 9 times out of 10 it'll stay factored. See, I kind of got that? So those are kind of straightforward. You factor them and cancel and you're done. All right, let's look at number 4 in this same section. Now we're getting a little bit trickier. That's a subtraction problem, right? Now, if we were subtracting fractions, what would you tell me? How do you subtract fractions? You got to find the LCD, least common denominator, right? You got to have the same denominator. If you do not have the same denominator, you cannot combine like terms. For example, if I had 7 over 10 minus 5 divided by 10. Let's say I had that. Let's say back in the 8th grade, we had that. 7 over 10 minus 5 over 10. You would determine that what? Your denominators are the same, right? So as long as your denominators are the same, you can do what? Combine your top. Add or subtract the top. Okay, so here we got the same denominators, 10. So we would go on and say, okay, that's going to be 7 minus 5, 2 divided by 10. And then you would reduce that and you'd end up with 1/5. Does everybody understand that, right? So what did we just establish? As long as your denominators are the same, you can combine your top. As long as your denominators are the same. Look at problem number 4. That's a lot of crazy looking stuff, right? Okay, but the only thing we're looking for one thing. Are those denominators the same? Yes. They are the same, right? So we're in good shape. As long as the denominators are the same, we're in good shape. All we have to do is combine the top. So let me start combining the top. And this is what you got to be careful of. That doggone negative right there. So when I combine the top, look at how I do it. I go 2x plus 9. But what else? Minus x. But I also need to put minus 2. Why minus 2? Because that negative right in there, this negative right here, changes everything behind it in the numerator. So had that been a negative 2, I would have put a positive 2. Now this will all be over what? This will all be over x squared minus 49. Right? All right. So we combine the top and we keep going. Let's see what happens. So can we do anything in the top, in the numerator? What can we do? Combine like terms, right? So 2x minus 1x will give us just plain x. 9 minus 2 will give us a positive 7. And there we go. We're done, right? We're not done? Why? It looks like maybe I can factor that bottom and something may cancel. That's what you have to be careful of, because again, multiple choice test, that's going to be answer choice A right there. Right? And you haven't even done anything wrong. It's just that you didn't finish. So you're going to put A as the answer if you're not careful, because that is kind of right. It's kind of right. It's just not factored completely. What do we need to do instead? At the bottom, we have the difference of squares. So what we need to do is factor the bottom. And like he said, the bottom will be x plus 7, x minus 7. Right? Now what happens? X plus 7's cancel. And look what answer. Let me tell you what answer choice B is going to be for those who are not careful. Answer choice B will be x minus 7. And if you put that, you're going to be wrong. Instead, the answer should be what? The answer should be 1 over x minus 7. Because when everything at the top goes away, you still have a 1 left. Now, when everything at the bottom goes away, you don't need that. But when everything at the top goes away, you still get a 1. But they know them, again, they know the mistakes you're going to make, and they have that answer waiting on you, because they know the mistakes you're going to make. All right. Number 5, I guess. Number 5 from that same section. Yeah, let me do number 5. Now you got to pay attention to this one, because this one's a little bit trickier. Now, if you look at number 5 on here, what's the problem with number 5? The denominators are different, right? So now we got a problem. The good thing about number 4 was what? The denominators were the same. So as long as the denominators were the same, we didn't have a big problem. We just had to combine the top and manipulate the problem, and we were done. On number 5, however, the denominators are distinctly different. So we got a lot of little work to do. Okay, so how do we get started? You get started by making sure you factor your denominators first. You're right back to what? Factoring. You see how important it is? Y'all going to get tired of me saying that. Factoring is so important. So, 2x plus 1. And when I factor this second term, factor that for me. Very good. Does everybody hear what he said? He said x and x plus 1. He pulled out the GCF. The GCF was x. And then he was left with x plus 1. Very good. All right. So now we got everything factored. So now, just like if you were doing this, let me take y'all back to 8th grade again. If I had, let's go back to this 1/2 plus 3/5. Can y'all see that? If we had 1/2 plus 3/5, I want to go back to that. If I had 1/2 plus 3/5, your denominators are different, right? So the first thing you'd have to do is find a common denominator. What's your common denominator here? It's 10, isn't it? So the first thing I would do is say, okay, both of my denominators need to be 10. And then how would I proceed from there? What do I do next? I would ask myself, well, how did they get from 2 to 10? And the answer would be what? They multiplied it by 5. But whatever you do to the bottom, you got to do to the top. So that's why that 1 would have became a 5. Y'all remember this from a long time ago? Some of y'all was not too long ago. Some of us, I graduated in 79, so that was a long time ago for me. Now, we got the 10 and the 5. So you ask yourself the same question. How did they get from a 5 to a 10? They multiplied by 2. So now 3 times 2 would be 6, and your final answer would be what? 11 over 10, and you'd be done, right? So that was just a little nostalgia, going back, taking you back to your high school days, or junior high, whatever. All right, so keep that in mind. I did that for a reason, because I just wanted you to see the procedure. They find a common denominator, then they ask themselves, how did they get from the old denominator to the new denominator? All right, so the first thing we got to do is find what? Common denominator, right? All right, so we got an x plus 1, we got an x, and we got an x plus 1. So what do you think the common denominator is? The common denominator will be x and also x plus 1. The rule is you need one of everything and the thing with the highest power. So we really need an x and an x plus 1. That becomes my common denominator. Y'all get that or no?
Yes.
Okay. Now, we're going to kind of go back to the 8th grade stuff. So remember when I had that 10 and the 5? I said, okay, how did they get that 5 to the 10? And you told me 2, right? So my question this time is, if my old denominator is x plus 1,
Missing an X.
and my new denominator is x and x plus 1, what is it missing? It's missing an x, right? So then, that means you have to put x's like that, because it's missing an x. Yes, no?
Yes.
That makes sense? All you're doing is putting what's missing. All right, what's 2 times x? 2x. Very good. Y'all got that? All right. Now, here's my old denominator, x and x plus 1. Here's my new denominator, x and x plus 1. What's missing? Nothing. Right? Nothing's missing. So if nothing is missing, then what do you have to do to the numerator? Nothing. You just leave it alone. Does that make sense?
Yes.
That because your old denominator was the same as your new denominator, there was no need to change anything. So you leave your numerator exactly like it is. Now that we've done that, we need to do what in the numerator? Combine like terms, right? So we got 2x and we got 1x, so what do we end up with? 3x plus 3 divided by x and x plus 1. And then we're done. Nope. Why not? Because the top or the numerator can be factored. All right, so let's factor it real quick. So you can pull out a 3, x plus 1 divided by x and x plus 1. What happens? The x plus 1s will go away, and you're left with 3 divided by x, and you're done. That make sense? Yes, no? You'd like to see another one like that? Are you good with that, or what? What we need to do?
I would like to do
Number
number 6.
6? 7?
We can do number 6 though, without part.
You need to see the answer? Yeah, you factored out the 3. You were left with x plus 1. At the bottom you had x and x plus 1. And then you canceled it. And you had 3 divided by x. Make sense? Okay, for those of you who just walked in, we're in section 4. But that's all I really had from that section. Is there other problems on there that we didn't do? Is there a problem we didn't do that you'd like to see? Vicky, how are we on time? I need to speed up. Huh? Okay. All right, so you need to see another one from section 4? Number 8? Okay, read it to me real quick because I don't have it on this sheet. A squared minus 4.
Over a squared plus 4a plus 3.
Okay.
Divided by 2a minus 4.
2a minus 4.
Over a plus 1.
A plus 1? Okay, thank you. All right, so here's another typical problem that you might see on the test. And I'm almost sure you'll have one similar to that on the test. Okay. So we got several things involved here. We got to know how to factor, we got to know how to flip, and we got to know how to cancel. All right, so let's start in the numerator real quick. A squared minus 4, that is the difference of squares. You factor that, what do you get? You get a plus 2, a minus 2. Okay, in the denominator, you have a trinomial with lead coefficient 1. You factor that, what do you get? a plus 3, and a plus 1. And again, we've done enough factoring. If you're not certain how I got that, just kind of go home and look at it again and look at the notes. Now, we have a division problem. So what happens to this division problem? It changes to a multiplication problem. So instead of division, we now have what? Multiplication. Not only do we have multiplication, but that back expression will now invert. So the a plus 1 was at the bottom and now goes to the top. The 2a minus 4 goes to the bottom, but let's factor it as well. What can we do with the 2a minus 4? You can take out a 2, and then you're going to be left with what? A minus 2. Is that right? Yes. All right, now we can just start canceling that. So what can we cancel? I see an a plus 1 I can get rid of. I see an a minus 2 I can get rid of. Can I get rid of anything else? At that point, you're done. In the numerator, we have what? A plus 2. And in the denominator, we have 2, a plus 3. And we're done. And the question was, well, would they multiply that out? Sometimes they might. They might multiply that denominator out and get what? 2a plus 6. So you got to be careful of that. All right, that's all on section 4, because we do have time restraints. Number 5, go to section 5 real quick. I can almost assure you that you'll probably have one of each of those on the test. Something like one of each of those. Now, we call these complex fractions because you have a fraction within a fraction, which makes it a complex fraction. Now, how do we get started on this? Now, you already know that dividing by a fraction is the same thing as what? Multiplying by the reciprocal, right? That's what we just talked about. You just told me to flip that thing over and change it to multiplication, right? So we're going to kind of do the same thing here. We're going to take the 3m over 7, and we're going to multiply it by the reciprocal of that bottom term. Y'all following me? We got a division problem. I'm changing it to a multiplication problem. So instead of writing n divided by 14m, what am I going to do? I'm going to write that as 14m divided by n. Does that make sense? Okay, so the only thing I did is flipped it, so I'm going to multiply it now. But before I multiply it, I want to make this a little bit easier. I don't want to have to deal with these big old numbers. So I look at that 7 and that 14, and I can do something to that, right? 7 goes into itself 1 time. 7 goes into 14 2 times. That's going to make it a little bit easier to knock that out. You don't have to worry about big numbers at the end. Now, can you leave it like it is and do it? Of course. Except at the end, you'll have to reduce it, and the numbers will be a little bigger. Now, what am I multiplying? 3 times 2? 6. M times m. M squared. In the denominator, I have 1 times n. I'm done. You should hope to have a couple of those on the test. That's pretty straightforward. Right? Ain't nothing complicated about that. Yes, ma'am?
So when you're multiplying, you don't have to have the same denominator?
No. If you're multiplying or dividing, you do not need the same denominator. Only when you're adding and subtracting fractions. Okay? Now, if you look at number 2, that problem is slightly different. If you notice in number 1, in the numerator I had a monomial, and in the denominator I had a monomial, meaning I had 1 term over 1 term. When it's like that, they're straightforward like this. Now if you look at number 2, in the numerator you have a what? A binomial, right? You have 2 terms. So it doesn't work the same as number 1. This is the way I do my problem, and everybody, like I said, will do it differently. I look at all of the denominators, and I find a common denominator. What's the common denominator? Up there. The common denominator is 3, right? So what I'm going to do then is I'm going to multiply everything by 3. I'm going to multiply this by 3. I'm going to multiply this by 3. And I'm going to multiply this by 3. So once I find my common denominator, I multiply everything by the common denominator. Now let's see what happens in the numerator. What happens in the numerator? Yeah, the 3 cancel, right? The 3's will cancel. Because you got a 3 on the top and a 3 on the bottom, so the 3's cancel. What are you left with? B plus 3. That make sense? So at the top, the 3 cancels. You're left with B plus 3. Okay, let's look in the denominator. What happens in the denominator? What happens though? 3's cancel again, don't they? So once the 3's cancel, what are you left with? 2. You're done. That's the answer. You're done. To me, that's the easiest way to do it.
And that's how you do all the problems like that?
All the problems like that. So for example, let me give you one a little bit harder just to let you see that it's true that this works like this. Let's say you had 3 over xy plus 1 over y divided by 6 over xy plus z over x. Now that looks real crazy, right?
Yeah.
You got all kind of mess in there. That's why you have to learn the concept and understand the concept. We look at all of the denominators, right? What are the denominators? X, Y, X, Y, X, Y. Right. So what's the common denominator? X, Y, right? The common denominator is X, Y. So then what you would do is go through and do what? Multiply everything by X, Y. Right? Multiply everything by X, Y. So this problem is a lot harder. Got a lot more stuff involved in it, but we're going to do the same concept. We multiply everything by X, Y. What happens in the first term right here? X, Y cancels. What happens in the second one? The Y's cancel. What happens down here at the bottom? X, Y cancels. What happens right here? The X's cancel. What are you left with? 3 plus X, 1X, divided by 6 plus YZ, and you're done. And that's how you would do any of those. Does that answer your question? This question was, do they all? Yeah, that's how they all work. If you do that particular technique. All right, that's complex fractions. That is complex fractions. And what else do we have? That was section 5. All right, section 6. I think I'm going to do section 6, and then I'll come to a stop, and I'll let Ms. Baker come up here. I'll stop on section 6, and then she'll work some, and we'll see what's left. Okay, section 6. Section 6, number what? You want to see? I'm going to let you tell me which one you want to see. Number 6? Anything before number 6. I don't even have 6 on here, so I guess they want me to do the ones that are on here. I'll still do 6, but let me do the ones that are on here. Okay, now, as you come up to the middle of the test, now remember we made it through factoring and rational expressions, so that took us through about 20 problems on the final exam. And that was a lot of factoring involved. And you'll be on the test, you'll be like, wow, that's true. And the first 20 problems had something to do with factoring. Now, the next set of problems that you will encounter will have something to do with what? Solving equations, right? So the next set of problems that you look at on the test, you're going to have to know how to solve problems. Now, if you look at number 2, you look at number 4, what do you see about those 2 problems? 2 and 4, what do you see about 2 and 4? Well, besides equals 0, they need to be factored. That's what I'm trying to get you to see. So again, we're all the way in a whole different chapter now, and we are still factoring. So for example, if I had to do number 2 real quick, I look at that problem, and what do I see? What kind of factoring? It's not difference of squares, because 3 is not perfect, and 11 is not perfect. Not illegal moves either. GCF, right? Isn't that where we always start? GCF. So what's the GCF in number 2? X. So when you pull out the X, what are you left with? 3x minus 11 equals 0. So again, factor it first, set it equal to 0, and then see what we got. Now, there's a rule in mathematics called the zero product property. Some books call it the zero factor theorem, and it says this: if A times B is equal to 0. Think about that. I want you to think about that. If A times B is equal to 0, in other words, I multiply two things together and I get 0, then what must be true? One of them things had to be 0. Right? I mean, if you multiply two things together and you get 0, one of them things had to be 0. Right? Okay, so now that we factor this, we got x and 3x minus 11 equals 0. One of them things got to be 0. So that means that what? Either x is equal to 0 or what? 3x minus 11 must be equal to 0. One of them things got to be 0. And some books say or both of them could be 0. Well, if x equals 0, that's already solved for you. There's no work to do. X equals 0. X is already isolated. 3x minus 11 equals 0. We got to do some work, a little bit of work, right? So how do we get that x by itself? We got to get rid of that negative 11. So what do we do? Add 11 to the left. But whatever you do to the left, you got to do to the right. So we know 3x is equal to 11. Now what? Divide both sides by 3. So now we know what? X is equal to 11/3. And those are your two answers. And the reason why I know I had two answers is because x squared tells me that I have two roots. If you wanted to check it, which is not always easy to check it, but if you wanted to check it, the 0, you would plug it in here. 3 times 0 is 0. 11 times 0 is 0. 0 minus 0 is 0. If you had to check the 11/3, you'd go 3 times 11/3 squared, which is 121 over 9 times 3, blah, 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 minus 11 times 11/3, 121 over 3, it will be equal to 0. But that's too hard to check sometimes. So you got to know you're doing the right thing. Now, so some of these problems, when you solve them, you have to factor them first. Y'all understand what I'm saying? Some problems that need to be solved, they have to be factored first and then solved. Now, if you look at number 3, however, do I need to factor anything there? We're going to go back to 8th grade on that one. Cross products, y'all remember that? That this time this will be equal to this time that? I can almost assure you'll have one of them on the test. Right? That's pretty straightforward. How would you work that problem right there? Yeah, all you got to say now is what? 2x must be equal to 12. Divide both sides by 2. So therefore, x must be equal to 6. And we are done. Right? But you probably won't get but one of those. So don't count on too many. Don't count on too many of those. And again, number 4, you would do what to number 4? I don't want to do it, but what would you do to number 4? Number 4, what would you do? Factor it, right? Difference of square. X plus 6, x minus 6 equals 0. Set each piece equals 0. You're done. All right. I'm saving number 1 to the end. That's a little bit harder. And number 5. Well, let's do number 5 first. You think they have one like that on Vicky? You haven't seen it? Because they normally don't put those. So, all right. So y'all going to have to take notes on this. This is a little bit harder. Number 5. Now, let me give you a little cheating way to do this. Okay? Let's say, I hate to even show you this. But remember, we're just trying to pass a test, right? And common sense is worth more than a whole lot of stuff. So let's say you were taking a test and you saw that problem and you had 4 answer choices there. A equals 7, B equals -3, C equals 0, D equals 4. And you know you got to get this problem right. This one you got to get right. And you can't take no chances, so we're going to cheat on it a little bit. We're going to take these numbers and plug them in and see if they work. What's 7 plus 5? 12. And 7 minus 1? 6, right? What's square root of 12? 3 point something, right? But it's not equal to 6. Man, we're done with that one. Right? Let's try the -3. Well, -3 plus 5 is 2. The square root of 2 is 1.4 something something something. I forgot. And you put a negative 3 right here. That ain't gonna work. Right? Let's try the 0. 0 plus 5 is 5. The square root of 5 is 2 point something. 0 minus 1 is negative. That ain't gonna work. Let's put the 4 in there. 4 plus 5 is 9. The square root of 9 is 3. 4 minus 1 is 3. Bam, we done. Now I want to show you the right way to do it. We got to know the right way to do it. We're going to do it the right. We got to be true to the math. Got to be true to the math. All right, this is how you do it. This is complicated. Not complicated, but it takes a little work. Now, just like anything else, when you have x plus 7 equals to 3, for example, how do you get rid of that plus 7? Subtract both sides by 7, right? You would subtract both sides by 7. And if you had x minus 10 equals to 4, how would you get rid of that minus 10? Add 10 to both sides, right? And if you had 2x equals to 6, how would you get rid of that 2? You would divide both sides by 2, right? And if you had x over 11 equals to 2, how would you get rid of that 11? Multiply. All right, so in math, to get rid of something, there's always a way to get rid of it. To get rid of something that's added, you always subtract. To get rid of something subtracted, you add and so on, right? To get rid of square roots, we have a way to get rid of it. And how is that? You square them. So to get rid of a square root, you have to square it. A square will negate a square root. A cube will negate a cube root, and so forth. When the index and the power are the same, they negate each other. All right, but if I square the left-hand side, I got to square the right-hand side as well. Remember, whatever in math, whatever you do to one thing, you got to do to the other. All right, so let's square the left-hand side. Square root of x plus 5 squared will give me what? Just plain x plus 5. Very good. Just plain x plus 5. X minus 1, when you square it, what do you get? X minus 1 squared. What do you get? And don't say x squared plus 1. Because I know that's everybody, a lot of people think that. Which is what? And that's right. He said that you got to go x minus 1 times x minus 1. See, a lot of people just go x squared plus, they square the x and they square the negative 1. But instead, you have to do the FOIL method on that. You got to go x minus 1 times x minus 1. And I'll just give you what you get. When you FOIL that out, you're going to actually get what? X squared minus 2x plus 1. Y'all see that? So, I mean, I know you can do that. If you take x minus 1 times x minus 1 and do FOIL, you'll get x squared minus 2x plus 1. Just do the FOIL method. Okay? Now, we got a problem here. We got x plus 5 on the left. X squared minus 2x plus 1 on the right. So what do we do next? You got to always add like terms. Just like when you get ready to wash your clothes. What's the first thing you do when you wash clothes? For those people who know how to wash clothes. What's the first thing you do? You put out, not before you do that, I start putting all my like stuff together, right? You put your white stuff together, your color stuff together. Before you solve any problem in mathematics, no matter what class you take, you always put your like stuff together. You can't proceed until you put like stuff together, which means that x needs to go over there with his buddy, that 5 needs to go over there with his buddy. All right, so how do we get rid of this x? Subtract x on both sides. How do we get rid of this 5? Subtract 5 on both sides. Now look at what happens. We get 0 equals to x squared minus 3x minus 4. Here we are deep into this package again, and what are we back to? Back to factoring. So if you're not convinced by now how important factoring is, I don't know what to tell you. We all the way in section 6 of this package, and we are still factoring. That's how important factoring is. All right, so now we got x squared minus 3x minus 4. We got a trinomial with lead coefficient 1. I'm going to go ahead and factor this. And what do we get? Anybody know? We get who? X plus 1 and x minus 4. Right? You get x plus 1 and x minus 4. You set each one of those equal to 0. So therefore, x plus 1 equals 0 tells me x is equal to what? Negative 1. Or x is equal to what? Positive 4. Well, you should say, okay, you got two answers. Negative 1 and 4. Why was the answer only 4? Because when you put that negative 1 in here, watch this. Go back to the very original problem. If you put a negative 1 in here, negative 1 plus 5 is 4, right? Square root of 4 is 2. Negative 1 minus 1 is what? Negative 2. So when you put the negative 1 in on one side, you get 2. On the other side, you get negative 2. That thing don't work. It's an extraneous root. It doesn't work. You did everything right. You didn't do anything wrong. It just doesn't work. And sometimes that happens in math. Now when you put the 4 in there, 4 plus 5 is 9. 9 is 3. 4 minus 1 is 3. That makes sense? All right, let me do number 1, then I'm going to let Vicky, you almost ready? All right. I know you're getting tired back there, it looks like. Okay, if you look at number 1, this is probably a little bit trickier than the others. This was actually in chapter 11. And most instructors only hit it real quick and was done with it. You know, you didn't do a lot of it because you didn't have time. All right, if you look at number 1, x squared equals 4 minus 2x. The first thing I need to do is set this thing equal to 0. So I'm going to start moving stuff around. So, oh, I'm sorry. I knew that. I was waiting for somebody to say that. All right, so here's what I'm going to do. I'm going to put everything on one side of the equation and set it equal to 0. That's the way quadratic equations are solved. So I'm going to say x squared. I move this negative 2x over. What happens to it? Becomes positive 2x. I move this positive 4 over. What happens? Negative 4 equals to 0. All right, so we're in good shape now. So we now have a quadratic equation, and it looks like we can go ahead on and factor it, right? All right, so, and the way we factor it is we look at the back number, which is what? Negative 4. We need two numbers to multiply to give me negative 4 that add to give me 2. So what two numbers do I need? Positive 2 and negative 2, that'll give me negative 4, but when I add it, it won't give me the 2 I'm looking for. 1 and 4, maybe? Because that won't give me the 2 either. This one is not factorable. So now we done ran into one that is not factorable. We hadn't run into that yet. Because everything we've been able to do at this point, we could factor. So here's what you have to do, and I need to use a different sheet of paper for that. If I have any. All right, here's what we have to do for that. Quadratic formula. You know the quadratic formula? Yes, no, maybe so? Can anybody tell it to me? Oh. You reading that or you got that in your memory? Huh? You read? Okay. All right. There's in other words, when you get ready to solve an equation and it's not factorable, because up until this point we were able to factor everything. And we factor it nice and neat, and we set each thing equal to 0 and we were good. So now we look at this thing and we cannot factor it. So we have to use something called the quadratic formula that says you can always find x by looking at negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now some of you said that's just one I'm gonna miss right there. I ain't gonna worry about that. Now this, you can do this. It's not a big deal. It's not a big deal. So this is the formula for quadratic formula. It will give you the values for x. All right. So the first thing you have to do is identify your a, your b, and your c. Your a is attached to the x squared. Whatever number is attached to the x squared. And I don't see a number right there, so we know that it's a 1 in front. We know that it's a 1 in front. Okay, b is 2 because it's in front of the x. And c is negative 4. Okay? All right, so now we know A, we know B, and we know C, and our job now is to take those values and plug them into the formula. All right, here we go. We're going to plug this into the formula. All right, just like I look at it like it's a recipe. You got your ingredients, you got a recipe. Let's start plugging the ingredients into the recipe. So my recipe says that I need negative B, or the opposite of B. But right now B is 2, so I need what? Negative 2. Plus or minus the square root of. Now my formula says I need what? B squared. Well, B is really what? 2. 2 squared will be 4. Minus, okay, A is what? 1. And C is negative 4. So let me just write those down. That's a little bit hard. A is 1 and C is negative 4. Okay? All divided by 2 times 1. So right now all I'm doing is plugging numbers into a formula, right? All right, so let's keep going because I know we're getting short on time. All right, so that's going to be negative 2 plus or minus the square root of 4. Now, we got a negative 4. That minus 4 is the same thing as a negative 4. So negative 4 times 1 times negative 4, what's that going to be? Positive 16. Very good. Positive 16. All divided by 2. Okay, y'all with that? Y'all follow that? All right, so now, that's going to be negative 2 plus or minus the square root of 20 all over 2. Right? Okay. Now, you learned in chapter 10 how to simplify radicals. So we know that the square root of 20, I can break it down to be 2 pieces. The square root of 4 times the square root of 5. So we know that the square root of 20 is really what? 2 square roots of 5. Y'all see that? Y'all remember that? That's kind of the last thing you probably did in class. 2 square. So now we really have what? Negative 2 plus or minus 2 square roots of 5, all divided by 2. Right? It looks like 2 divides into all 3 of these numbers, right? So our final answer will be what? Negative 1 plus or minus the square root of 5 over 1, which you don't need. Y'all see how I got that? No? Not really? Yeah? Look. 2 hours. All right, so all I did is said, okay, once I got to this point, I said, well, 2 divides into this, and to this. 2 goes into negative 2, negative 1 time. 2 goes into this, that cancels, you just get square root of 5. 2 goes into this 1 time, which is at the denominator, you don't need it. So at that point, you are done. Y'all get that?
Yeah.
And that's how you solve a problem when you cannot factor. You have to use quadratic formula. I believe that's about it.